Moving on with the vulnerability list on Hacksplaining, here we're at 16% now, and the next item that we're going to start tackling in this video is CSRF, CSRF, or cross-site request forgery. In this video we're going to look into the attacks, and in the next video we're going to look into the defenses, and we're also going to do the quiz. So let's start with the attacks. If an attacker can forge HTTP requests to your site, they may be able to trick your users into triggering unintended actions. So this is very bad. Now, when creating a website, we tend to code the client side and the server side together. We build pages and forms a user will interact with on the client side, then build the server side URLs that respond when a user performs an action. So far, so good. However, requests can be triggered to the server-side code from anywhere else, not just from the client-side code we write. This is one of the most powerful aspects. So, that on the side, I believe this is probably one of the best explanations or the best introductions to CSRF. Because that's exactly how it's done, and you probably better understand cross-site request forgery, or let's just say simply CSRF for the purpose of this video. When you create a website, you do the client side and the code side. So you build the pages and forms the user will interact with on the client side, then build the server side that actually responds to when the user performs an action. But this can also happen from external, so can also happen externally, because requests can be triggered not only from the server side, from the client side code that you just have written, but also from the server, but also from anywhere else. So this is one of the most powerful aspects of how internet is designed. So in the greater light of things, if you think about it, it actually is like that. It allows linking between websites, but it also is the cause of a common security flaw, CSRF. A CSRF attack occurs when a user is tricked into interacting with a page or a script on a third-party website that generates a malicious request to your site. So all your server will see is an HTTP request from an authenticated user, if the user is authenticated and the session is maintained on your website in that particular browser. That has to be specified as well. However, an attacker takes control over the form of the data sent in the request to cause mischief. Imagine you run a microblogging service that allows your users to tweet their their opinions at each other in 280 character sized chunks. So you have Tweeper maybe. Mal is a hacker who has noticed that posts on your service are created using GET requests. Yeah, I've seen that yesterday, so it seemed really odd to me in an application security test that I was doing yesterday, that resources are being created via GET requests, and that's probably one of the very, very few circumstances where I've seen that scenario. This means that all the information is carried in the URL of the HTTP request. So yeah, maybe for convenience purposes, but it's totally violates all the security rules. Don't carry a lot of information, or don't carry a lot of actions, or do not perform things in the URL of the HTTP request. Mal modifies the post creation URL to include a malicious payload. So as you can see here, you have post message this blah 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 to include a malicious payload. Now he has to find some way to get a victim to visit the URL in their browser. So the victim should actually visit this link. How do they do it? Vic is one of your users, so Mel has been able to guess his email address. classic scenario. Has science gone too far? Research have taught the horse how to do karate. Okay, this is a weird horse. Mel sends Vic an email with a very tempting link pointing to the crafting URL. So this is a classical case, as I've said, of not necessarily phishing, but it's a scam. What if it starts teaching to the other horses karate? Vic clicks on the link. So, wait, did I just post that? I don't think I did. So your server interprets the request as Vic writing a post and creates a new item on his timeline. This is not the action Vic intended, but he may not quite have noticed what just occurred. Now, in this situation, Tweeper did not have a content security policy, did not have different specific security headers set that would prevent this to happen, because in this situation, this tweep has been triggered by Vic clicking in his email. So if tweep would have had good security measures set in place, it would not have allowed websites or actions of users being called from anywhere else other than their origin, which is what happened in this situation. The post is designed to be enticing enough that other users of your site will click on it. When they do, they will be tricked in the same way Vic was. Like in this situation, is being hidden in behind this short link. You now have a worm on your site, as each user who clicks the link will open a set of new potential victims. Yeah, and that has actually been seen in the past. Now we know how cross-site or CSRF works. Let's actually learn how to protect against it. So that's actually the subject for the next video.